Welcome to the lesson on manufacturing engineering. Upon completion of this lesson, learners will be able to analyze the importance of process planning for manufacturing, construct and assess an input-process-output diagram, and explain how process maps and process charts support communication plans. Let's consider a surgeon and their operating team. Once the surgeon has the supporting staff he needs to conduct a surgery, they must develop a plan to execute the surgery and a clear way to communicate it. Similarly, manufacturing engineers are involved in most of the manufacturing processes, from the planning stages to the packaging of the finished product. Their main function is to optimize those processes to provide the company with a competitive edge. For this purpose, they must work well in teams and be capable of communicating manufacturing plans effectively. Process planning is a very important step in manufacturing, the objective being to generate and communicate a clear and concise description of how the product should be created and the flow of related materials in the plant. Process planning should be the first responsibility of the manufacturing personnel, as it directs the setup and organization of resources needed and formulates the actual production processes. In some instances, process planning might even influence the shop's design or layout. The manufacturing engineering department aims to optimize processes to give the company a competitive edge in production. Process planning involves a series of steps. These include producing or obtaining good product drawings that contain all the relevant information that is easy to read and understand, analyzing the drawings and separating the product to be manufactured into its parts, identifying the process and the sequence required to produce the parts per the drawing specifications and reporting them, and assigning all relevant resources including time associated with each process. This information is usually recorded in a detailed document referred to as a process map or process chart. A process map or process chart is a tool that gives a visual representation of the relationships within a process. An input-process-output diagram, also known as IPO diagram, illustrates the relationship of the process input factors, and the finished product. IPO diagrams are useful because they are simple yet effective in identifying how a process impacts the input, which then yield the output. The example you see here shows an abbreviated version of what you might find in an IPO diagram. To construct an input-process-output process map, there are 5 steps to follow. First, start by identifying the inputs and outputs of the process. This involves listing everything that goes into the process and the expected results or outcomes. Second, list the steps of the project. Document each phase or activity involved in transforming the inputs into outputs, ensuring each step is clearly defined. Third, identify the outputs for each step. This means noting the specific outcomes or products produced at the end of each individual stage within the overall process. Fourth, determine the parameters of each step. Parameters are specific factors that influence the process, affecting how inputs are transformed into outputs. Lastly, classify the parameters into their categories. The 4 categories for classifying parameters is listed here: noise factors, controllable factors, procedures, and critical factors. Noise factors, N, are variables that are not part of the process itself but may introduce variability affecting the consistency or quality of the output. Controllable factors, C, are aspects that can be actively managed or adjusted during the process. Procedures, P, are standardized methods or protocols that guide specific steps. Critical factors, CR, are the most influential parameters that have a significant impact on the success of the process. Here is a simple example of an IPO diagram that illustrates the EV battery manufacturing process. The inputs are essential materials and resources, including raw materials, specialized equipment, quality control tools, and trained staff. The process typically flows through 4 stages: cell assembly, module assembly, pack assembly, and testing and quality control. Each stage has specific parameters. For example, cell assembly requires precise temperature control, pressure monitoring, and adherence to material specifications, while module assembly focuses on cell configuration, electrical connections, and cooling system integration. Pack assembly involves overall pack design, battery management system or BMS integration, and thermal management considerations. The final testing stage ensures quality through voltage testing, capacity verification, and comprehensive safety checks. This process typically yields 3 main outputs: the completed battery pack ready for vehicle integration, detailed test reports documenting performance metrics, and quality certifications confirming the pack meets all required standards. For many processes in manufacturing, proper communication is essential. Once the process plan is developed, it can be used to convey key elements of production to the appropriate personnel. For example, the process chart can be used to supplement training or as a basis to analyze the causes of deviations from quality standards. As stated previously, the process plan should be communicated to relevant workers, as it is important for them to understand where their work fits in the big picture of the product creation. Workers should be aware of the product requirements, operating procedures, and expected production levels to ensure that the final output meets the company's standards. This can also support creative and efficient thinking in finding solutions to quality or throughput problems. A lot of process plan communication involves documentation and tracking of processes. As seen on the process chart shown here, communication is appropriately and specifically traced step by step. This not only helps clarify product specifications, but also keeps everyone informed about tasks. Other methods of documenting communication within the production process include having relevant workers from a shift sign the forms describing their work. This allows for communication between shifts. Archiving emails and memos sent via intranet into the company's server and recording meeting minutes are other methods of documenting communication. In general, a written record of important communication is valuable as it can serve as a reminder of heard information and help convey the seriousness of the discussed issues. In summary, process planning is important to manufacturing as it establishes the resources including equipment and personnel, production time, and production rate of the company. Input process output diagrams are used to determine what inputs and outputs each step of the process requires. Lastly, process maps and process charts aid in the communication of plans to technicians and engineers by establishing operating procedures and quality parameters. Thank you.